Go away. Math 9 through 12. All right, let's do the graphs. When you were in grade 10, you did that. Remember grade 10 math? Y is equal to mx plus b? What type of line is that? Yeah, slope intercept, linear, straight, whatever. What does m represent? Slope, which is rise over run. You're going to see in calculus, slope is like, we call it something different, but it's like 3, 4, it's like a fundamental part of calculus. The other formula, if you remember it, was y2 minus y1 over x2 minus x1. Okay? What does b represent? That is the y-intercept. What's the value of x at the y-intercept? Yeah, that's when x is equal to 0. Okay. So if you had... How do you know if it's a linear... Actually, hang on. If I said y is equal to 3x plus 2, how do you know that's linear? Just looking at the equation. The degree of 1, right? If the highest exponent is 1, the degree is 1, it is linear. So it matches. It has a y-intercept of 2, a slope of 3, which is actually like 3 over 1. Go up 3 over 1. Remember all this stuff? Up 3 over 1. There's your graph. All right. Then you moved on to grade 11. What was grade 11 all about? Quadratics. So there's a few different ways to write quadratics. We have this, x squared plus... So you can write it like this. General form. What does this tell you? What can you do with this form? You can factor it. What multiplies to 2 and adds 3? So that gives you x plus 2, x plus 1. Why is it good to factor? What information does it tell you? X-intercepts. Yeah, whoever said that. X-intercepts. What are the x-intercepts here? -2, -1. What shape is a parabola? Not a V, but it's that shape. With intercepts of -2, -1. What's the y-intercept on a parabola? How do you know that from just looking at the equation? Turn x to 0, so it's always the constant term, right? So this is the y-intercept, which is 2. Does this graph open up or down? Why? Positive leading coefficient, the number in front of x squared. So there you go. I don't care about the min. Where this is, this point right here, we're going to learn to find that with calculus on more complex graphs, and it's super easy with calculus. You could do the average of -2 and -1 and find it. It's going to be -1.5, but it's easier with calculus, so we're not going to worry about that. I'm just looking for general shapes here. Okay, so we got that. That's grade 10, grade 11. Then you went on to grade 12. What did we do in grade 12? Pretty much everything else, right? Come on. Three, grade 12. So we did a bunch of different things. We did absolute value. Do you remember the absolute value graph? What does that look like? That's the V, right? Okay. Then you did transformations, which moves it. So if we went absolute value of x plus 2. Which way did we go? You went left. Just ask yourself, what makes the inside 0? Negative 2. So that means we went left 2 units. It just moves the graph left. Look, you don't have to know these graphs, but it helps. It'll help. If I did the absolute value of x plus 3, come on, plus 3. If it's outside of the absolute value, what does it do to the graph? It moves it up and down, right? 3, boom, boom. Okay, that's absolute value. I'm not going to worry about reciprocal. We're going to do stuff with that later on. I want to come back to quadratics. What if I have this? Okay. Y is equal to x plus 1 all squared minus 3. This is a quadratic, right? Because of the degree 2. That's how you know it's a quadratic. So you know it's going to be a parabola. Does it open up or down? Down because of the negative, right? So you know it's going to face down. What do these two numbers tell you as opposed to when you write it this way? It's not the y-intercept. What are these two numbers? It's slightly different than this. When you factor it, you get the x-intercepts. It's h and k. It's the shift. These numbers give you this point. Okay? So if it's plus 1, ask yourself, what makes the inside of it 0? Negative 1. So that means you went 1 to the left. So we went 1 left. And what does the 3 do? 3 down. So this graph is 1 left, negative 1, and 3 down. That's your vertex. You just told me the graph opens down because of that, right? Okay, so we know it opens down, so that's really all you have to draw. Okay, that makes sense? Yes? Okay. The only other one, we'll do one polynomial. We'll do it in factored form. X plus 1, x minus 2, x plus 3. So, this is a polynomial. What are the x-intercepts? Yeah, so you just look at, when it's in factored form, you just look at the brackets. What makes each bracket 0? Negative 1, 2, and negative 3 for the last one. Okay. Is this, what's the degree and what's the leading coefficient? So what's the degree of this function? It's going to be 6. You add up the multiplicities, right? Because they're being multiplied together. If you multiplied all this out, don't do that because it's going to be a gong show. You have to have x plus 3 times x plus 3 times x plus 3 times x minus 2 times x minus 2 times that. So it's going to be huge. But if you just add the multiplicities, you get 6. Leading coefficient is 1, positive. All we really care about is that it's positive. If the leading coefficient is positive and the degree is 6, both arms are up, right? So That means you start here and you got to end here. So we come down. We have to go through -3. What does this multiplicity of 3 do at that point? Yeah, it's the point of inflection thing. And again, in calculus, we do this, and it spits out answers in a different way. So it allows us to answer more specific questions. But so it does that. It's a point of inflection. Turns around. It has to go through -1. What happens at -1? Just goes straight through because you have a degree of 1 or a multiplicity of 1. Turns. It has to go through 2. What happens at 2? It bounces, called a tangent, because we have a what do you call it? A multiplicity of 2, and it goes like that. In calculus, we'll learn how to find these points very easily, okay? And it'll spit out points of inflection, because points of inflection can occur up here, not just on the x-axis. All right, calculus will tell us all that information. Okay. Okay, one more thing, and then I'll give you a few questions to practice. All right. What intercepts of I want the x and y intercepts of y is equal to x cubed minus 4x. So, what's the easier one to do? X or y? Okay, why is the y-intercept easier? Because x is 0, right? So the y-intercept, you go, that's just x is equal to 0. You put in zeros for all your x's. I mean, you don't have to show this, but I will. You end up with 0. So you get 0, 0, which means we go through the origin. Okay? X-intercept. You make y is equal to 0, and then you solve it. How do you solve this? Pull out an x. Get x squared minus 4. What's x squared minus 4? Plus or minus 2. It's the difference of squares. So then you get x is equal to 0, -2, and positive 2. Those are your x-intercepts. Don't do this. At this point, you could have done this, or people will do this. They'll move the 4x over, like that. And then what they'll do is they'll divide off the x. You get 4 is equal to x squared, and then they go, well, just square root both sides, and you get plus minus 2, right? It's not wrong. Well, it is wrong. Because when you divide off variables and make them disappear, you lose one of your answers. So just be very careful when you do that, okay? It's preferable to factor it. If you ever are in this position where you're dividing off variables, you're probably going to lose one of your answers, and you need to be conscious of that, okay? So factoring is the preferred method because then it all pops out. All right? Okay, peoples. So either on your electronic version of your book or your hard... Did anybody go get a hard copy?
Can I go get one right now?
Yeah, you can go. Just give me 1 sec to do this. You're going to do questions 1 through 3, 5 to 13, and 19 to 25, but you're only doing the odd ones because the odd ones are the ones with the answers in the back. And then I'll pull up a website here that you can pull up on your phone, or if you have an Android phone, you can download the app that'll give you all the answers and show you all the work in the book. Okay? All right. So remember the textbook's in the classroom. You can download it, or you can just open it up right there, or you can go to the library right now and grab one. And I'll give you some time to work on these before we move on to the next stuff.